All right, let's take a look at question 10. In question 10, we're going to be learning about how to transform quadratics. Question 10 says, given the parent function f of x equals x to the third, the function g of x equals x minus 1 to the third minus 2 is the result of a shift of f of x. So which of these describe the shifts of this to yield that function right there? Before we get started, let's do a real quick review on our shifts, our transformation of functions. So recall the following. If you have a function composed with x minus h, this represents a shift h units to the right. Now this is kind of interesting because you have a minus here, and you would think intuitively that when you compose a function with x minus an integer, it will cause a shift to the left, but it's actually backwards. Okay, so f composed with x plus h, in this case you have a shift h units to the left. Okay, so whatever is grouped with the x, you're looking at the opposite. Okay, the opposite effect, that's what's going to happen. But when you have a function and you add a number to that function, that's going to be a shift k units up. And then when you have a function and you subtract a number from that function, there's going to be a shift downwards. Okay, shift k units down. Alright, so let's take a look at what the situation is that we're dealing with in this problem. Okay, alright, so in this problem we have g of x equals x minus 1 to the third minus 2. So let's write down our general formula right next to it and see what's going on. So generally we have g of x. This is going to be x minus h. Actually, a function of x minus h. Well, let's adapt it here. So it's x minus h to the third plus k. Okay? All right. So let's break down the two transformations that are happening here. The first one is we have g composed with x minus 1. In the original function x to the third, the x was replaced with x minus 1. So that is equivalent to this right here. So if you have x minus 1, guess what that means? G of x minus 1, which is basically x minus 1 to the third. This indicates a shift in the x direction. But is it to the left or to the right? Is a shift 1 unit to the right, as indicated here. Okay, if you have x grouped with a number, you do the opposite of what the sign in the center says. And then we also have g of x, the function. So let's make a real quick correction here. This is f. We had f composed with x minus 1. And then we also have f of x and a number subtracted, f of x minus 2. Do you know what this causes to happen if you have f of x minus 2? When you subtract a number from a function, that causes the function to shift either up or down. But if it's minus, it's going to shift actually 2 units down. Okay? So shift 2 units down. So basically, the number that you're adding to the function as a whole represents your vertical shifts. So this is up and down. F of x minus 2 applies to this particular scenario right here. So the function minus a number will result in a vertical shift downwards. Okay? But when you're composing a function with x plus or minus a number, that's a horizontal shift, and then minus goes to the right and positive goes to the left, and then for vertical shifts, minus goes down and plus goes up. Alright, so the shifts that are going to happen from x to the third, which is f of x, to g of x, is 1 unit to the right and 2 units down. Answer to question number 10 is option number 3. Thanks so much for taking the time to watch this presentation. I really appreciate it. We would also like to know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions, comments, or special requests, you can feel free to post it in the comments section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for other cool review tutorials such as this. More resources, worksheets, games, and tools can be found at math.serve.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.